Good day everyone. Today I will discuss to you what is trees, heaps, and graphs in data structures, and I will show to you some examples to make you more interesting to listen and learn. Binary tree is the data structure to maintain data into memory of program. There exists many data structures, but they are chosen for usage on the basis of time consumed in insert, search, delete operations performed on data structures. Binary tree is one of the data structures that are efficient in insertion and searching operations. Binary tree works on O log n for insert, search, delete operations. This following program would be working basic program for binary tree. This function would determine the position as per value of node to be added, and new node would be added into binary tree. Lines 13 to 19 check first if tree is empty, then insert node as root. Line 21 check if node value to be inserted is lesser than root node value. Then line 22 call insert function recursively while there is non-null left node. Line 23 check if node value to be inserted is greater than root node value. Then line 24 call insert function recursively while there is non-null right node. Searching is done as per value of node to be searched, whether it is root node or it lies in left or right subtree. This search function would search for value of node whether node of same value already exists in binary tree or not. If it is found, then search node is returned, otherwise null is returned. Lines 47 to 49 check first if tree is empty, then return null. Lines 50 to 51 check if node value to be searched is equal to root node value, then return node. Lines 52 to 53 check if node value to be searched is lesser than root node value, then call search function recursively with left node. Lines 54 to 55 check if node value to be searched is greater than root node value, then call search function recursively with right node. Binary tree is deleted by removing its child nodes and root node. This function would delete all nodes of binary tree in the manner left node, right node and root node. Line 39 check first if root node is non-null, then line 40 call deltree function recursively while there is non-null left node. Line 41 call deltree function recursively while there is non-null right node. Line 42 delete the node. Binary tree can be displayed in three forms: pre-order, in-order and post-order. So let's try to run this program. If works, the output would look like this. Heap sort is a comparison-based sorting technique based on binary heap data structure. It is similar to selection sort, where we first find the maximum element and place the maximum element at the end. We repeat the same process for the remaining elements. What is binary heap? A binary heap is a complete binary tree where items are stored in a special order such that value in a parent node is greater, or smaller, than the values in its two children nodes. The former is called as max heap and the latter is called min heap. The heap can be represented by a binary tree or array. How to build the heap? Heapify procedure can be applied to a node only if its children nodes are heapified. So the heapification must be performed in the bottom-up order. So let's understand this example program code. I used Java program for implementation of heap sort. Build heap rearrange array. 1 by 1 extract an element from heap. Move current root to end. Call max heapify on the reduced heap. To heapify a subtree rooted with node I, which is an index in R. N is size of heap. Initialize largest as root. If left child is larger than root. If right child is larger than largest so far. If largest is not root. Recursively heapify the affected subtree. A utility function to print array of size. Driver code is often just the class that contains a main. So let's try to run this program. If works, the output would look like this. A graph is a common data structure that consists of a finite set of nodes or vertices and a set of edges connecting them. A pair x and y is referred to as an edge, which communicates that the x vertex connects to the y vertex. Graphs are used to solve real-life problems that involve representation of the problem space as a network. Examples of networks include telephone networks, circuit networks, social networks, I show you a C program to demonstrate adjacency list or representation of graphs, a structure to represent an adjacency list node, a structure to represent an adjacency list, a structure to represent a graph. A graph is an array of adjacency lists. Size of array will be V number of vertices in graph. A utility function to create a new adjacency list node. A utility function that creates a graph of V vertices. Create an array of adjacency lists. Size of array will be V. Initialize each adjacency list as empty by making head as null. Adds an edge to an undirected graph. Add an edge from src to dest. A new node is added to the adjacency list of src. The node is added at the beginning. Since graph is undirected, add an edge from dest to src also. A utility function to print the adjacency list representation of graph. Driver program to test above functions. Create the graph given in above figure. Print the adjacency list representation of the above graph. So let's try to run the program. If works, the output would look like this. Thank you for listening. That could be all. Goodbye and God bless.